We're going to talk a little bit today about new frontier for Skycatch and our customers, where we're applying both our existing technology as well as new technologies that we're developing with our partners to use AI and obviously drones for energy site management. All right, so I'll give this short introduction. We'll go through a little bit of background, kind of set the foundation, a little bit about how things are done today and what we think is a potential better way to do those things. And then I'll go over maybe some things we've learned, and then we can do Q&A. So I'm the head of product at Skycatch. We are an end-to-end solution for drone data. One thing that's really unique about Skycatch that we've applied for our customers is extremely high accuracy without the use of ground control. And we're sort of bringing that forward into our new efforts, expanding beyond overhead mapping and getting into more vertical things. Yesterday I gave a talk about vertical mapping and inspection for buildings. Same thing applies for wind turbines, and we'll even talk about beyond the data capture today of how we actually make use of the information that you've collected. So customer of ours that we're using sort of as the example scenario today is Goldwind. Goldwind, largest energy company in China, wind energy, and third largest in the world. They're in the Americas, they're in Europe, they're obviously in China, and they're growing tremendously. And so they've got a lot of really interesting things that they want to do, interesting problems to solve. We'll talk a little bit about where we're going to focus, which is they have a great process. They're very good at building wind turbines, and actually they're good at building and running the farms too. But what they're seeing is that the greatest opportunity for improvement is actually not in the turbine itself, but in how do they employ it, how do they install it, how do they run the farm, how do they manage the farm. So some background here on AI, and I'm not an AI expert. I'm interested in knowing enough so that I can apply the right pieces of it to my customers' problems, right? We have a team of AI engineers. Those guys are probably experts, and they're really good at the nuts and bolts. But I want to elevate us out a little bit and think about how are we going to make use of that? There's a million frameworks out there. There's tons of open source material. There's tons of technologies. We have to find out how to apply it and get value out of that. Otherwise, it's just a science experiment. So there's a great framework from Maria Yao here, and you sort of follow the dots from left to right. So as machines get more intelligent, far left is ACT. ACT is like the cruise control in your car. If its speedometer goes below the thing you set it at, it applies some throttle and speeds it back up. Same thing with the thermostat in your house. Taking that a step further is predict, right? And that's where a lot of the work is done today. How do we have smart models that can make predictions? They take the data we have and they say, hey, looks like you're going to miss your numbers this month, or you're not selling enough to hit your targets, and you need to make a change. Going on to learning is it's actually taking feedback in and getting better at that prediction every time. Create is where it's, if you guys have heard of generative design, where we're actually having software design better bridges in ways that humans haven't come up with. Relate is one, we don't need to get into it, one step beyond that. Master is where humans are, that's us. And then evolve is singularity and superhuman or transhuman supercomputers. So we're going to focus on really predict and learn today. Also useful, just as you think about this and as we're thinking about how do we apply this technology, think about the anatomy of a task. And this is from the same person here, but what we want to do is we want to get really good at the blue. But we have to start on the left side and get good at those other things too. So we can think about on each step of, as we're talking through this, where are we? Are we talking about the action? Are we talking about feedback? Are we talking about predictions? Are we talking about outcomes, hopefully? Why are we even talking about this? Why is this an important topic right now? It's because job sites are getting actually less efficient. They're getting more complex. We want to turn that around. We want to do better. These large industrial sites, tons of machines, tons of people, actually a lot of information out there that we're not actually making use of. So let's find some tools and some solutions to make them work better. So for purposes of today's discussion, we can think about these wind energy farms as having 4 phases, right? So scouting is, it doesn't exist, and we need to find a place that has the right amount and type of wind. Then we move on to accessing that site. And I have a picture later, but most of these sites, and as we build more of them, they're extremely remote. They're typically in mountainous and hilly areas, and typically in forested areas and places without roads. So that's a big step too. Then we have to actually build the farm, right? And then we can get into operations and maintenance, right? So have that farm start generating revenue, and we start dialing that in and getting that efficient and effective. That's where we're really going to talk the most today. But we at Skycatch are applying our technology to all of those phases together with Goldwyn. How's it done today? A little bit more on the scouting. You find the wind. Today, how they do that is with satellite imagery. In DEMS from satellite. Pretty low res, but good enough. They find the wind. Again, it's typically in these crazy remote areas. And then they do their best to get a 3D model or some aspect of a DEM of the site and start running it through simulation modeling. Why? Because they need to know where to install the turbine. They got to make a build plan. Today, this takes a month per site. With Skycatch, with our drone technology alone, without applying AI, we're getting that down to a week. And I hope that we can start to apply AI and make that even better. For the accessibility, you guys might have seen some of these images and videos on the internet before, but the act of bringing these 30-plus meter long blades into a really remote area is a big effort. And they're designing trucks and equipment to just do that piece alone. And so Goldwyn is actually using our drone mapping technology to map out this process, because a lot of times they actually have to build roads, and they need to find a way that's actually drivable to bring this material in and to bring the cranes and everything else. Then the actual build or construction phase. This is a pretty standard sort of construction process. There's earthworks involved. They have to dig a big pit. We help them measure that and keep that on track. They fill it with cement. They bring in all the parts of the turbines and assemble them and use cranes to actually erect it. And that's an important part, which sort of leads us into the operations and maintenance phase and where we can apply some new tools, right? So getting all those turbine parts and out there and strapped to some crane and lifted and installed tends to cause some damage. And so what you don't want is you don't want to hand over from the build project to the operations team and have them start off at a disadvantage. And what you also don't want is you don't want to delay that handover. So we want to start to use inspection to catch that right at the beginning. So challenges with that today, they do it manually. It's really time intensive. It's honestly not very accurate, and it's definitely can be unsafe depending on which method they use. You typically have not good records, typically very low resolution, and any learning that comes out from that tends to be siloed or not in a format that you can share across projects. So it just gets left on that farm. We want to change that because that's slow and it's not scalable. We need to scale. Our customer has really, really, really big, aggressive growth plans. So what could be a better way? So here's our proposal. Where we want to go is we want automated data capture. We want to empower and enable the field personnel to start to train the models. We want that to happen everywhere so that we can get good models. And then we use federated learning to get that training from each of the field sites up to the master and then back down so everybody benefits. And then we go ahead and, again, apply that for an outcome. So, good things about automated inspection, really safe, really repeatable, high-resolution data. It's consistent, and then the learning from that, as opposed to the old way, can be shared. And this makes it scalable. It also makes it fast. So putting some numbers to that, or some comparisons, 15 to 20 minutes for the drone flight versus something like 4 hours for a human to do it, whether they're doing ropes or telescope. In addition, that ropes and telescope method, typically what they're doing is they're taking notes. Maybe they're snapping some photos, but honestly, the angles aren't that good. It doesn't have good coverage. With the drone, we're getting 4 sides of the blade. We're getting 2 edges and we're getting 2 faces, right? All of that gets archived. And then we can run our AI to learn, to find the defects, and make some predictions and tell people where are the problems. So a little bit about object detection with AI. So the challenge is these defects tend to be very small. You can have trailing edge fractures that are millimeters. You can have sort of paint or laminate peeling away that honestly is not visible to the human eye. There may not be a color difference, or maybe from a distance you wouldn't be able to just pick it up. But we can use software, and I've got some images later that allow our models to actually detect these things much more effectively and consistently than humans. And then the last thing, as part of the solution, is, again, we're growing the models, we're applying them, but we're also applying them to a maintenance schedule, right? So every farm has some maintenance schedule today. There's preventative maintenance. They do some frequency of inspections of varying degrees. We can actually amp that up. We can actually do really deep inspections, non-intrusively, much more frequently at a very low cost. Why does that matter? Because if we catch the problems when they're tiny, then they're easy to fix and they don't become big. That's huge for the business. What you don't want is downtime on that turbine. A little bit about training data. We divide this into two groups. So we do controlled environment or simulated, and then we do real world environment. The beauty of the simulated environment is that we can generate vastly more data. We can simulate edge cases that would take years and years, and maybe we would almost never get to if we tried to do it out in the field. We can use computer vision techniques today to have a wide array of training data just in the office. It's very fast, it's very cost effective, and it's very it catches all the cases that you might even think you want to encounter. Once we do that, we can go out into the real world, and we can do these in parallel, but in the real world, then you can get some really good labeling and training data from the experts out in the field. So how do we propose to get the training data? So this is where our products come in. And we believe that, again, empowering those field workers, the ones who are directly tasked with maintaining these wind turbines, those are the ones that are actually the most motivated and the most capable of training the models. So on our Edge 1, we run a software called Learn 1, which is a labeling and training interface. It also allows them to run the models and get predictions, and it also connects up to our cloud to train the master. In doing this, and in putting these all over each of these farms, we're multiplying the amount of training data that's going to be available. And we're getting it from the best source possible, which means our models are going to be getting to be the best that's possible. Once we have those models trained really well, then we use Edge 1, like I said, to run predictions. We'll get them on the spot. When the drone lands, it's going to run the model on the photos that were collected, and you're going to get information, and again, trying to get to those outcomes, you'll be able to take action on the spot right there. So a little more on learning, things that we've done, things that we've learned so far. Sort of just as an overview, deep neural networks on blades. If you've worked in this space before, this is sort of normal stuff, but just as an overview, we're actually segmenting the blades to find the different parts. And then we can run models on each of those parts because they each have their own unique defects that we're looking for. Trailing edge is different than leading edge. The tip is different than the base. Once we do that, we classify everything as defective or not. Going back to the simulated environment, there's just some examples here of simply changing various parameters of the photos, such as the color spectrum or pixelating things. It's actually allowing our models to get significantly better at identifying the blades, the parts of the blades, and finding the problems on them. And this is like 1% or 0.1% of what we're actually running. And a lot of the work has been on generating all of this simulated training data, and the payoff has been huge. It's accelerated the models tremendously. But if you think about it, in a lab environment, it's hard to simulate some of the real-world conditions. You're always going to have changing light conditions. You're going to have shadows in places that you wouldn't be able to well predict. Maybe there's clouds one day and there's not the next. Maybe there's a little bit of moisture on the blade one day and there's not another day. So those are all things that we want to knock out immediately. So going to the bottom line, right? Why are we even working on this? Why does it matter? What do we think about the potential value? So we think that the annual savings per wind farm through all of this starts out at $700K per year, which easily for the business is a simple decision, right? That's drone, service, flying all the time, piece of cake, right? So that's when it starts. We actually think that as the AI gets smarter, as the models get better, the savings is going to get even larger. We're going to start to factor in even greater cost avoidance because we're catching defects when they're really small before they become a problem at all. And the last thing, also extremely important for these companies, for our customers, is safe. They don't have to put people on ropes anymore. And that's really important. It's really valuable for them.